Beneath the turbulent waves of the Aegean Sea, a violent storm in the spring of 1900 forced a crew of weary sponge divers to seek refuge near a small, unforgiving island. When the waters finally calmed, they descended into the depths, expecting only the familiar harvest of the ocean floor. Instead, they stumbled upon an underwater graveyard that would ultimately shatter our understanding of human technological evolution. The divers had discovered the remnants of a massive Roman cargo vessel, a shipwreck that had rested silently on the seabed for over 2 millennia. In 1901, a painstaking recovery operation brought a staggering haul of antiquities to the surface, including magnificent marble statues, intricate glassware, and a heavily encrusted, unassuming lump of calcified rock and corroded metal. At first glance, this particular artifact seemed entirely unremarkable. For months, the corroded mass sat in the courtyard of the National Archaeological Museum in Athens, largely ignored as curators focused on the more glamorous bronze and marble statues. It was not until May of 1902 that archaeologist Valerios Stias noticed something profoundly anomalous. As the wood and sea debris dried and cracked apart, a distinctly mechanical feature was revealed, a perfectly formed gear wheel with triangular teeth embedded within the stone. The presence of this gear triggered an immediate intellectual crisis within the archaeological community. According to the established historical timeline, complex clockwork of this nature was not supposed to exist in ancient Greece. The prevailing consensus placed the invention of sophisticated geared machinery centuries, if not millennia, later in human history, making this artifact a profound and deeply unsettling anachronism. The artifact, soon to be known as the Antikythera Mechanism, challenged the very foundation of classical history. For decades, the true nature of the device remained obscured by heavy calcification, leaving scientists to speculate endlessly about its purpose and origins. It hinted at a highly advanced, lost technology that defied the established narrative of ancient engineering capabilities, yet the evidence remained locked inside a stone-like shell. The investigation took a critical turn in the mid-20th century when physicist and historian of science Derek de Solla Price dedicated himself to unraveling the mystery. Price hypothesized that the corroded lumps were the fragmented remains of an intricate astronomical calculator, a device designed to model the movements of the cosmos. Proving this theory, however, required peering inside the solid rock without destroying the fragile bronze within. To test his hypothesis, Price collaborated with nuclear physicist Charalampos Karakalos in the early 1970s, utilizing gamma-ray and X-ray radiography to penetrate the dense accretion. The resulting images were blurry and difficult to interpret, yet they provided the first undeniable proof of the device's staggering internal architecture. The X-rays revealed dozens of interlocking bronze gears, precisely cut teeth, and evidence of a differential gear system previously thought to have been invented during the Renaissance. The revelation of this internal complexity forced a radical reassessment of ancient scientific prowess. The artifact was not a simple, static astrolabe used for basic navigation. It was a dynamic mechanical computer. It was an analog device capable of calculating complex celestial movements with a level of precision that historians had previously assumed was impossible for the ancient world. The quest to fully understand this ancient Greek marvel entered a new era in the early 2000s with the formation of the Antikythera Mechanism Research Project. This international team of scientists and historians realized that standard X-rays were insufficient for mapping the precise three-dimensional structure of the fragmented gears. They required technology that could virtually slice through the artifact with microscopic accuracy. The team secured the use of a massive custom-built microfocus computed tomography scanner, a piece of equipment originally developed for inspecting the structural integrity of aerospace components. The high-resolution scans yielded breathtaking results, producing three-dimensional models of the internal bronze gears that were unprecedented in their clarity. More importantly, the scans illuminated something entirely unexpected hidden deep within the metal fragments. Embedded within the corroded layers were thousands of microscopic text characters, essentially serving as a highly detailed instruction manual inscribed directly onto the machine's casing. Researchers painstakingly deciphered this ancient Greek text, which confirmed Price's early theories and drastically expanded our understanding of the device's capabilities. The inscriptions detailed a sophisticated user interface designed to track the lunar calendar and predict solar events. The mechanical architecture relied heavily on the Metonic cycle, a period of exactly 19 years, or 235 lunar months, after which the phases of the moon recur at the same time of the solar year. The device modeled this complex astronomical period with a large spiral dial on its rear face, demonstrating a profound synthesis of observational astronomy and advanced mathematics. Furthermore, a secondary lower back dial physically modeled the Saros cycle, a period of approximately 18 years, 11 days, and 8 hours, which ancient astronomers used to predict both solar and lunar eclipses. The machine's capability extended beyond mere calendar tracking. It could physically model the irregular elliptical orbit of the moon, a complex celestial phenomenon known to scientists as the first lunar anomaly. Replicating this lunar anomaly mechanically required an ingenious and highly sophisticated pin and slot mechanism. This specific gearing arrangement allowed the moon pointer on the front dial to vary its rotational speed, moving faster when the moon was at perigee and slower at apogee. This mechanical mirroring of the night sky was executed with a precision that bordered on the miraculous. The realization that ancient engineers could mathematically model and mechanically reproduce such intricate celestial mechanics fundamentally alters our perception of human history. It proves that the Hellenistic world possessed a society far more technically advanced and mathematically sophisticated than previously documented in surviving historical texts. The Antikythera Mechanism stands as physical proof of an intellectual zenith. Yet, this profound discovery opens a chasm of new, deeply perplexing questions for historians and archaeologists alike. If such a masterfully crafted astronomical calculator existed around the 2nd century BC, where are the developmental prototypes? The archaeological record should theoretically be littered with simpler, earlier versions that led to the creation of this ultimate masterwork. The historical record remains frustratingly silent on the matter of widespread mechanical engineering in antiquity. While scattered texts by authors like Cicero mention Archimedes constructing a bronze orrery, no physical evidence of a broader mechanical tradition has survived the ravages of time. The singular nature of the Antikythera mechanism creates a massive anomaly in our understanding of ancient industry. This device stands alone in the archaeological record, a towering peak of innovation without a visible mountain range of supporting technological development. The absence of similar devices points toward a highly specialized, fragile technological ecosystem. It strongly implies that this level of engineering was confined to a small elite group of artisans or philosophers, rather than being a widespread industrial capability. When the Roman Empire expanded its reach and the Hellenistic world subsequently fragmented, this highly specialized mechanical knowledge was likely extinguished. The intricate bronze gears were perhaps melted down and repurposed for weapons, armor, or currency. The profound astronomical purpose of the machine was tragically forgotten in the fires of conquest and the shifting tides of empire. Historians hypothesize that the loss of this specific technology set the field of mechanical engineering back by at least 1,000 years. It was not until the development of massive, intricate astronomical clocks in the cathedrals of medieval Europe that humanity would again see geared mechanisms of comparable complexity and mathematical precision. The shipwreck itself adds a final, poetic layer of intrigue to the narrative of this lost technology. The doomed vessel, heavily laden with luxury goods destined for wealthy patrons in Rome, served as an unintentional time capsule. It preserved this singular piece of genius beneath the crushing pressure and preserving silt of the sea, hiding it from the very civilizations that forgot how to build it. We are forced to consider the sheer improbability of its survival. Had the ship safely reached its destination, the mechanism might have eventually been discarded, melted down, or lost to terrestrial decay. Instead, the disaster that claimed the lives of the crew ultimately safeguarded the greatest technological achievement of the ancient world for over 2 millennia. Without that fateful storm in the spring of 1900, the true capability of ancient Greek engineering would remain entirely unknown to us today. The Antikythera Mechanism survives as a solitary ghost of a lost technological age. It is a silent, corroded testament to the boundless brilliance and ambition of its long-forgotten creators. As modern scientists continue to study its intricate dials and painstakingly decipher its faded inscriptions, the machine serves as a powerful reminder of the fragility of knowledge. The trajectory of human progress is rarely a straight, unbroken line marching inevitably toward the future. It is a delicate thread, vulnerable to the chaotic forces of history. This ancient calculator proves that humanity is capable of reaching extraordinary intellectual heights, only to have that knowledge slip away into the shadows of time. The Antikythera Mechanism remains our most compelling evidence that sometimes the most astonishing technological leaps are not found by looking forward, but by carefully excavating the deep, silent mysteries of our past.